In this video, the degrees of freedom will be explained with a visual representation. Degrees of freedom are the number of variables that are free to vary in a system. There are three different types of degrees of freedom: translational motion, rotational motion, and vibrational motion. The three different types of degrees of freedom can be accessed at different conditions. Translational motion is any motion along the three planes, x, y, and z. Now, let's think of a dancer as a whole molecule. Here, we see a dancer moving side to side, back to front, and in and out of space. This is an example of translational motion. For translational motion, there are always 3 degrees of freedom. These 3 degrees of freedom are not affected by the monoatomic, diatomic, polyatomic, nonlinear, or linear molecule. These degrees of freedom also do not depend on temperature. Translational motion is the first type of degrees of freedom, which means that the molecule, if it has energy, has translational motion. The second type of degree of freedom is rotational motion. Rotational motion is 2 atoms within a molecule turning around a center focal point. Here, we see a dancer that is rotating around her center of gravity. This center of gravity runs straight through her torso, separating the molecules from head to toe. Thus, her head can be imagined as one atom, as her feet can be the other. This is a representation of rotational motion. With rotational motion, unlike translational motion, the number of degrees of freedom that come out of it are dependent on the structure. These structures can either be monoatomic, diatomic, polyatomic, linear, or nonlinear. Rotational motion also is independent of temperature. The third and last type of a degree of freedom is vibrational motion. Vibrational motion is motion along the joints of 2 atoms. Vibrational motion, unlike the others, comes in many different forms. The 5 types of vibrational energy are stretching, rocking, wagging, twisting, and scissoring. Stretching is when 2 molecules move farther or closer to another. Here we have the dancer's 2 arms moving farther and closer away from her body. Bending would be when 2 substituent groups move farther and closer to each other, but the molecule that they came off of, they are the same. On the dancer, you can see her arms moving forward, closer to each other, and then them pulling farther apart. The next one of these vibrational energies is rocking. Rocking is when 2 substituent groups keep the same distance from each other, but change the angle that they have with the atom that they come off of. Here you can see her arms moving back and forth, changing the angle with the atom they come off of. Next, we have wagging. Wagging is when the substituent groups move up and down, keeping the angles between each other, the 2 substituent groups, but changing the angle between the atom they come off of. This is different than rocking because they are moving up and down the plane rather than side to side. The last form of vibrational energy is twisting. Twisting is when the 2 substituent groups rotate around the atom that they come off of, but are not moving as one whole unit as they did in rotational motion. Here you can see the 2 arms moving around the whole dancer's body, as the body stays in the same spot. All of these different forms fall under the category of vibrational motion. These 3 forms of motion that affect the degrees of freedom we see as students and teachers as one thing at a time, not them on top of each other. But in a model, the 3 types of energies, translational, rotational, and vibrational, are all happening on top of each other at the same time. Here we have a dancer which is superimposed onto another dancer, which is superimposed onto another one. The 3 dancers are all doing their different forms of motion, vibrational, translational, and rotational, but they're happening at the same time, which is realistically what is happening inside of a model.